Hello, my name is Andy Steve Juntin, and I'm currently studying Electronics Design Lab, Section 04 under Dr. Jahana Ermi. We have been tasked to discuss one of the safety mechanism or design behind electrical or electronic devices for consumers. So I have decided to go with CPU, mainly about its thermal overheating safety shut-off mechanism. How does it work? What does it mean? It means that I'm interested how CPU shuts down after it operates beyond certain temperature limit. Let's see why is it so important. So firstly, number one, it's important because it allows the device to last longer. You see, if you expose materials like polymers to high temperature, they get weaker. This is because of the thermal expansion causing stress and strain onto this material. And we know that CPU produces a lot of heat, and this heat contributes to to the increment of temperature on this material. So by having this limit set, we can make sure the device lasts longer. Okay, number two, we want to prevent possible battery rupture. In all modern electronics devices, they run on lithium-ion battery technology. This battery technology is extremely heat sensitive. If the device operates beyond its intended design, this battery might rupture and go up in flame. So by having this temperature limit, we make sure it doesn't go up. It doesn't burns during operation. Okay, number three, we want to ensure system stability. As most people are aware, the electronic components within electronic devices, they are susceptible to noise and corruption caused by temperature. This is because of the physical property itself within the conductors and diodes, etc. So by having a certain limit on how hot it can go, we can reduce the noise and data corruption to the optimal level. Okay, number four, we want to prevent damage on the thermal sensitive electronics components. Okay, what are these components? These components, like I said earlier, batteries are thermal sensitive component. This as well also include PCB boards, transistors, and also hard disks. Number five, we want to reduce the fire hazard caused by the device. There are recent news about how smartphones and tablets go up in flame when you put it on the bed or while using it. So by ensuring this mechanism works fine, we can make sure that the fire hazard can be reduced. Okay, let's see how does thermal overheating shut off mechanism works. So basically it goes back to the semiconductor physics, which states if you have sandwiches of P type material and N type material together, we have this value, this voltage value called junction voltage. You see right over here, this is the formula of the junction voltage. So you can see the function of the junction voltage is in terms of absolute temperature. You see, absolute temperature. So if the temperature rises up, the junction voltage also rises up. So let's take a look at the circuit down here. You see the little circuit we have in the corner. It looks somewhat similar to a Whitlar current source, modified Whitlar current source or current mirror. So when the temperature increases, the potential differences across the PN junction, which by the way on this the transistor on each transistor also increases. So if you have most of the voltage going to the transistor, it reduces the potential difference between the loads, active loads, whatever the load of the circuit. So to the certain limit, there will be a cut-off voltage where the current flow will be zero, because most electronics have this kind of thing, these diodes. They limit how how low the voltage can go before it completely turns off. You can see this while applying KVL to the circuit. I think that's all. Thank you.